Hello again. My name is Michael Steele. I'm still one of the Math 3 teachers at Franklin High School for the 2022-2023 school year, and I'm going to be working through problems from the Essential Skills quiz model that give you the opportunity to sort of see the types of questions you're going to run into on this more or less weekly quiz. Having said that, if I'm a little bit short in this video, it's because I did 2/3 of the video and then the file corrupted. First time I've ever had a file corrupt that way in years of making videos on this device. So just a little bit frustrated, just a tiny bit. But that's okay, because we're here to work through the quadratic formula, and the nice thing about the quadratic formula is it works in every quadratic equation. So basically there's something that's sort of nice in the background of this, doing it a couple times. But as with all the other videos, what I'm going to do here is, of course, work through each of the problems, but also just kind of talk about the techniques. In this particular case, because there's some calculator-based approximation involved, I'm going to also show you how to do some of that in the calculator. I don't have the exact calculator most of you will be using. I have sort of this clunky one that weirdly is really slow on my computer, but I'm just going to do as best I can and talk about the same strategy for inputting it. So without further ado, and also because I told myself I'd eat dinner after making this video, and now I have to do it again, let's jump right in. So the instructions here, pretty straightforward. They're the same for all three of the problems here because it's the same for every question. Number 4 on your Essential Skills quiz. Tell us to use the quadratic formula to solve for x, and then to write our answers in exact and approximate form, but rounded to the nearest thousand. So I've got space over on the right side of the screen for exactly that. But in here, the first instruction is to use the quadratic formula to solve for x. Now, whatever you think about the quadratic formula, if you've watched the previous video, you might think to yourself, oh, big brain moment, I'm just going to factor this. Yeah, good luck with that. What two numbers multiply to positive 10 and add up to positive 13? Well, yeah, no. Nice try, friend. No, it does not factor. This is a non-factorable polynomial. In fact, I believe this is true. Most polynomials, in fact, I know this is true. Most trinomials of this form are not factorable. It just happens that we spend a lot of time on the ones that are. So instead, we need a technique that's going to sort of push through that and sort of solve it, even though we don't have the ability to break it apart in that same way. And that technique is the quadratic formula. There's actually another technique out there called completing the square, but I'll follow the instructions here. So the quadratic formula comes from completing the square. There's a whole process for it. I can encourage you to look it up. But basically, the quadratic formula allows us to solve the equation ax squared plus bx plus c equals 0. So if your equation wasn't in that form, you'd have to get it in that form, and then you could. So we want to solve that equation, and the way we can is with this formula. And I actually pretty much always sort of perform it. I think it in my head to the tune of Pop Goes the Weasel, the little song that used to be in these little Jack-in-the-Box things. Not sure if that's still a toy. Y'all were born with smartphones, so who knows. But basically the way this works, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Not very good at drawing straight lines, sorry. So there it is. That will actually produce, as strange and as random as that always looks, that actually gives us the 2x values that are going to solve this equation. If you're wondering how there's 2 when there's just one expression, it's because of the plus or minus. One will give us 1, the other will give us the other. So plus gives us 1, minus gives us the other. So our job here when we start, at least when we're just trying to find the exact form of this, is simply to identify what a, b, and c are, and then to plug them into the quadratic formula. So let's demonstrate that with our first example here. In this case, a is 1, b is 13, and c is 10. Now you might think to yourself, oh, the signs don't matter. No, the signs do really matter. It just happens in this case all three are positive. We have a positive 1 sort of hidden there, or implied, positive 13 and positive 10. So the positives do matter. That's why I wrote them as positives. If a negative shows up on, say, oh, I don't know the next problem, since I already did it, we'll make them negative. But now that we have them, we're just going to plug them into the equation. So I'll do it as musically as I possibly can, although I'm going to cheat a little bit and draw the fraction bar first. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there we go. Everything's plugged in. That is our exact two values, sort of condensed into a single expression, but there they are. But of course, we want to be a little bit more descriptive than that, so let's try to clean this up just a bit. So what do we got in here? Well, first inside that square root, we're going to have 13 squared, which is 169, and then minus 4 times 1 times 10, which is minus 40. All that's over 2 times 1, also known as 2. From here, clean this up a little bit. The inside of that square root is going to be 129, and then all of this is divided by 2. This is going to be our exact answer. In fact, I'm going to write it over here just to get that out of the way for us. Try to write it as neatly as possible. As I said, keeping things straight up here can be kind of tough. So there is our exact pair of answers. That is 2 answers. And while I might personally prefer to write that as 2 separate answers, for the situation of the essential skills quiz where time is at a premium, totally fine with writing it that way. But our second question is, well, what are our approximate values? We should get 2 x values out of this. So what are those 2 values? To find those 2 values, we need to use a calculator. So let's do exactly that. So as I said, I don't have a perfect calculator here. Let me move that over just slightly. I have a different model from the ones that you have here. It's also, as I said, very, very slow to use. But we're going to do exactly that. So here we are. So what are we going to do? We need to punch this in, but we need to be really careful when we do this. First of all, we can't put in both answers at the same time. And second, we need to make sure that we adhere to the order of operations. Like if we just punch things in as we see it, we might not divide the correct things or divide the entire numerator by everything. So in order to do that, I'm going to use parentheses. So first, I'm going to do negative 13. I'm going to do the negative one first. So negative 13 minus. To get the square root, I'm going to go second and then squared. That gets us that little green square root up there. This will be 129. And then we'll close the parenthesis. And then now that they're closed, we can divide the entire thing by 2. Now on a normal calculator, you just press enter and it'll give you a nice decimal approximation. We don't have that luxury on this calculator. In order to get the decimal, I have to press that little button first and then press enter. When I do though, we get our first x value. It's going to be negative 12.179. Oops. Negative 12.179. So there's our first one. Came out pretty cleanly, but as I said, this is sort of awkward to work our way through. Now again, assuming you're using a scientific calculator, most of the models that you're going to use actually are really quick, have a quick way to get to your other one. You don't have to retype this entire thing. If you just go up and select that and press enter, it will copy the entire thing down. Then from here, you can just use the over arrow to go back to where that minus sign is. Eventually, as I said, this is really slow. Change it to a plus, and then press answer. When we do, we get our second value, negative 0.821. And there are our answers in both forms. There is our exact value, now that I fixed it, and then our 2 approximate values showed up as well. So there are our first answers to the first problem. That next brings us to question 4b, which is again using the quadratic formula. Not really any variation here. We're going to follow the exact same process that we did before. The only difference is some of our constants here, our a's, b's, and c's, might actually be negative. We'll have to account for that a little bit. So of course, just as we did before in 4a, we're going to start by identifying a as 2, b as negative 8. And remember that negative sign is important. It does need to be there and included. And c being equal to 7. So with those in place, we can now use the quadratic formula. So as I did last time, I'm going to draw the fraction bar first. So x equals negative b, and obviously just to pause the song for a moment, time. That's going to be positive 8. I'm just demonstrating it really carefully here to stick with the song itself. You can obviously do this in many fewer steps. I'm just being explicit as I go through this. On time. X equals negative b plus or minus the square root of b squared. Notice how carefully I am with the parenthesis. Minus 4ac all over 2a. Ta-da! So there is our answer. Again, both our answers, really. We've got our exact ones there. We just want to represent this just a little bit better. So let's do it. So negative 8, we said that'll be positive 8 plus or minus the square root. This will be 64 minus 8 times 7, or 56. And then all of this divided by 4. And if we clean that up just a little bit, we'll get 8 plus or minus the square root of 8, all divided by 4. And I would say this is probably the answer that I'm expecting most people to put just because of time. Like, I'd expect that to be what pops up. Now, having said that, that's not the only way you could write the answer. It's not even what I would call most simplified, although I don't believe that's what we're looking for on here. But if you did want to simplify it a little bit further, it would just depend on your ability to clean up the square root of 8. So as a heads up, the square root of 8 is the same thing as the square root of 4 times the square root of 2, which is, of course, then equal to 2 root 2. The reason I bring this up is that you could instead write this as 8 plus or minus 2 square root of 2 all over 4. And if you wanted to from there, you could notice that each of 8, 2 root 2, and 4 shares a common factor of 2. So if you divide 2 from each of those places, you'll get a cleaner expression. 4 plus or minus 1 square root of 2 all over 2. So this is also a correct version of that answer. So basically a couple different ways to write the exact one. I'm going to stick with the original one just because that's what's written on Ms. Nakamura's key as well, but at the same time both of these are fully correct and would be accepted, of course. So having said that though, we want to find those two values as, numeric values, things that we can quickly tell what their size is based on, decimal approximations. So to do that, I'm going to call into play our calculator once more. Let's clear out the work we were doing before. Let's punch this in. Just like last time, I'm going to use parentheses for that numerator. So 8 minus the square root of 8. I'm going to get out of the radical that time. I remembered this time. And then divide by 4. And then for this sort of annoying calculator, I'm going to press the little double triangles. That's going to give us 1.293. So our first value here is 1.293. And since we did the minus one, the negative, instead of plus or minus, we did the minus first, we're going to get the smaller answer first. That's always how I've tried to do it. So there's our first bit. Our second bit here, we need to do the same thing. So just like before, let's go up. Sort of copy and paste it down below. The only difference, we are going to put a plus in here and then repeat the process. 2.707, there it is, 2.707. And voila, there we have our exact and approximate values. Again, calculator to help out with the approximate, but otherwise just the quadratic formula sort of grinding and crunching its way through to our answer in exact form. Finally, we have question 4C, the last one of these, mercifully, after I've done this basically twice up to this point. Really don't want to do the quadratic formula again. So in this case, just as we did before, we've got our quadratic equation, 3x squared plus 4x minus 9, and we're going to go ahead and solve this. Just like before, we're going to identify each of those constants' values. So a is positive 3, b is positive 4, and c is negative 9. So now that we have them, again, making sure that we include the negative sign, that's not optional, do need that there, we can now plug it directly into the quadratic formula we know and love and or resent from the video stopping and breaking and corrupting in the middle. It's more me problem than a you problem. Forgive me. So what do we got? X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So there it is. As with before, we get our exact value. That is the correct two answers in exact form. They're just not as clean as they could be, and I'd like to do better, so I'm going to do that. So negative 4 plus or minus. On the inside here, well, we've got 16. Now over here we got minus and minus, so that's going to become plus. Really important that we nail that down. And then from here, I'm seeing 12 times 9, which is 108. So all of this is over then 6. So taking this just a little bit further, cleaning it up just a little bit more, that's negative 4 plus or minus. That's going to be 124, all divided by 6. And once again, we have our exact value. I'm in fact going to even write it over here. But just like with 4b, this isn't even the truly most simplified version. Like, I don't know that there's such a thing as a best. It's correct. It's the exact correct answer. But there is a better way of writing this if you know a little bit about breaking up radicals. So just like before, I'm going to take this root 124, and I'm going to factor it. Now, in order to do that, you might wonder, how am I going to do that? Like, how do I know that this one's going to break apart? And again, since you don't have to do this, if not, just skip ahead. You're probably watching this on 2 or 3 times speed already. I know how y'all work. But basically what I'm thinking here, this is a personal strategy. 124, I can see that that's a multiple of 4. So basically what I want to think about is, well, what do I know about 124? Well, I know that's 120 plus 4. And from here, again, this is the clever part, I know how to pull 4 out of both of those numbers. That's going to be 4 times 30 plus 1. And what that means is this radical is the same thing as the square root of 4 times the square root of 31, which means it's equivalent to 2 square root of 31. Again, everyone has their own techniques. It's just my personal one. But basically, from doing that work, we can rewrite this then as -4 plus or minus 2 square root of 31, all divided by 6. And then just like before, 4, 2, and 6 all share a factor of 2. It's in common. It's a GCF. A piecewise GCF. No, sorry, what is it? Like a pairwise GCF, I guess. So basically, we can pull out a 2 from each. We'll get 2, 1, and 3. And that will allow us to write this in one separate additional form. -2 plus or minus the square root of 31, all divided by 3. And again, we're not expecting you to write it this way. Obviously, if you want to, you can. But basically, we're not expecting you to simply because there's not that much time when you take an essential skills quiz. So we're just not focusing on that skill in this moment. But at the same time, it is the quote-unquote best or most simplified version of this answer. So I'll include it here for your amusement, your perusal, your information. There we go. Now, having said that, what we are including are the approximate answers. So let's get that in here. So just like with the previous two, I'm going to use parentheses for that numerator. And again, I'm going to go back to the unsimplified one here. So we'll go this. Notice I have learned from doing this 6 times. We'll close the parentheses. We're going to divide them by 6. The -1. Oh, look at that. I haven't done it on this video, but there it is. Notice I got the exact answer that I had done the work for, so I guess that's something. But I'm going to use those little double triangles to get out of that mess. -2.523. Oh, did I write down the right thing? -2.523. So there should be our first one. It's annoying that it disappears like that. And by the way, with the 5 after the 2, we do round up. And then for our second one, I don't want to type that all in again. It just wasn't the most fun in the world that I've ever had, but that's okay. I'll go up and select it, move over a little ways, annoyingly click. There we go. Turn it into a plus. Ta-da! 1.189. And there, good friends, are the answers to the third sample for question 4. So with all that said, I hope you had a great time, because I did not have a great time doing all of these problems multiple times because my computer was annoying. But if I keep talking and complaining about it, I could totally get burned by my computer once more and have it corrupt once more. So I'm just going to stop here and say that I hope you got some good information out of this. Hopefully you got a nice little refresher on the quadratic formula, maybe even learned a song out of it. And you feel really nice and refreshed on attacking quadratic equations that don't quite factor. So in any event, thank you for watching, and have a great rest of your day, night, week, or even a year. Because I'll be there. What is that? Is that the Friends theme song? I've never watched Friends. I've watched Friends one time in my entire life. What's wrong with me? Bye.